Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle. And it's called Forever Young by Proxy 14. I remember when I was a child, I remember there was a song, it was Forever Young. Was it Rod Stewart? I think it was Rod Stewart who sang that song. I don't know if it's a reference to that, but that just brought that to my mind. Anyways, here are the rules. We have normal Sudoku rules, which means place the digits 1 through 9 in every row, column, and box once each. We also have killer cages, where the sum of a cage cannot cross 16. So it can't be greater than 16. I remember, actually, let me just double check. I'll pause this for a little bit. Okay, I'm back. I just wanted to check what it was stated in the post, and you can have repeats in cages. So you do not have the normal killer cage Sudoku restraint of having. You cannot have repeats in a cage. You can, in this instance, have repeats in a cage. So, and the sum of a cage cannot be greater than 16. So it could be up to 16, but it cannot be greater than 16. So those are all the rules, actually. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, so this is interesting. So the sum of every cage cannot be greater than 16. It has to be 16 or less. And you can have repeats in a cage. What does that mean? That means this is at most. So this digit can be 1, obviously, but it has to be at least 1. So this is 9 here, which means this is 7, which is 16 minus 9 at most. So this has to be 1 through 6. This is 1 through 6. This is at minimum 1 and 2 added together plus 8. So that's 11. 16 minus 11 is 5 at most. So this is 1, 2, 4, and 5 here. We have in box 4, this is 16 digits at most. This is 16 digits at most. That's 32 for both of those cages, which means this is at least 13 in the rest of the box. That's interesting. What else do we have? Okay. This is 16 at most. This is 16 at most. So that means what's the most these can be? It has to be 1. So 16 minus 1, which is 15, plus 16. So that's 31. So this is at least 14. So this is 5, 6, 7, 8, or 9 there. So this is at least 14. It could be up to 17. We don't know which. 3, this is... Well, this is still pretty broad here. Okay. How many cages do we have here? We have 1, 2, 3, 4. 4 cages, which means... Right. For these 2 boxes, that could be... It adds up to 90. These 4 cages adds up to 16 times 4 at most, which is 64. that means the remaining cage, the remaining digits must add up to 90 minus 64, which is 26. So this has to be then 8 or 9, right? You can have 17 at most here. 17. Oh, wait, no, 26. Right. Okay, never mind. We know this is 9. So again, these 4 cages here are at most 16 each. 16 times 4 is 64. 90 minus 64 is 26. These two digits can be at most, what is it? 17. 26 minus 17 is 9, which is the minimum this could be. So this has to be a 9 then. So this is 9, which means this can't be 9. This has to be an 8-9 pair here, which means the rest of the row cannot be 8 or 9. What else do we have here? This is 9, so this is at maximum 7. Okay, so we know this has to have a 1 and a 2 here. It could have 3 or 4 here also, right? Because it's a maximum 16. So it's 3 or 4 here. This cannot, the rest of the box cannot contain 3 or 4. Oh, sorry, 1 or 2. So it's 3 through 9. This can't be 9, though. These can't be 8. This is 16 at most. This is 16 at most. That's 32 plus 7 at most. So we have, this is 7 at most because it's 16 minus 9. So 32 plus 7 is 39. That means this is at least 6 here. So this is 6, 7, 8, or 9 here. What other digits do we have? Okay, this is 1, 2, 3, 4, 5, 6 cells here. 6 cages, and none of them can be larger than 16. Oh, that's interesting. So we have 6 cages here. None of them can be larger than 16, right? So that means this is at most for these 1, 2, 3, 4, 5, 6 cages. They must add up to 96. Oh, but there's no restraint for this cell here, so that's fine. Right. This is at least 14. This can never be 9. Actually, it's 1 through 7. So the rest of row 7 is 1 through 7 here. This can't be 3. This can't be 3. 9 cannot be here. This is at least 10. So this is at most 6 here, right? We don't have very many restrictions here. Hmm. Okay, this is kind of interesting. What is this added up to? So this is one cage, two, or maybe just ignore this cage. Let's do this. One, two, three, four, five, six. Six cages here. So one, two, three, four, five, six. Six cages here. So that's 96. Is that right? Yeah, 6 times 16 at most is 96. Plus 7. So that's 103. Right? Yeah, it's 103 for these cells here. We have to get 135? Hmm. Hmm. Yeah, 103. 96, 6 times 9, 16 is 96. Plus 7 is 103. So that's 103 at most for these cells. That means we have 3 cells here. So we have 103. 103. These 3 cells have to be 15 at most because this could be 1. So 103 plus 15 is 118. 118. The remaining 3 digits can be 6, 7, and 9. So how many degrees of freedom does that give us? 6, 7, and 9 is 13. That's 22. So it's 140. That seems reasonable, right? So it's 5 degrees of freedom that we have. Hmm. Hmm. That's still a lot. Okay, so that's not very much that we can pin our hopes on. Hmm. This can't be 3 because of 3 in the row. What about just these? So this is 1, 2, 3, 4 cages. So that's 64 at most. This is 7 at most. So we have 1, 2, 3, 4 cages. 64 plus 7 is 71. This is 15 at most here. Ah, okay, I think I see something. So, okay, again, this with this being a 1, this is at most 15. So, okay, we have 1 cage, 2 cage, 3, 4, 5 cages here. 5 times 16 at most is 80, plus this is 87, right? So this is 87 here for this amount. Um, You could have repeats here, though. So this is 87. Subtract out 1 and 2. So that's 84. And this is subtract out 1. That would give you 83. So this would be, without these cells here, 83 at least, right? So again, you'd have 1, 2, 3, 4, 5 times 16, which is 80, plus 7, 87, minus 3, so it's 84, and minus 1, which is 83. So this is 7 or 9. We have then here 2 degrees of freedom, right? Because this is at most 1, 2, 3, 4, 5, 87 minus or plus 9. 87 minus plus 9 is 96. So, and this can be 3 at minimum. So this is 3 at maximum. If this were 1, these two would have to add up to 5 at most. So this can never be 5. Therefore, we know the 1 has to be one of these digits here, because it's either 1, 2 or 1, 4. Because the 3 cannot be in the same column. So it can't be 2, 3. So it's either 1, 4 or 1, 2 here. This can't be 1 then. So this could add up to 5. This adds up to 16 each at most. So this can't be 1 anymore. Obviously cannot have a 9. Sorry, an 8, because of the 8 in the column. What restrictions, what else do we have? This could be 6, 8, 1, 1. That is possible. What other restrictions do we have? Do we have any other restrictions? Not really. This is still pretty wide, right? This is 6 also. 1, 2, 3, 4, 5, 6 cages, which is 96. Plus 9 could give us 115. 105. And that's still a lot of potential there. So this is at least 7 here, which means this adds up to 9 at most. So this is 1 through 6. Oh, that's interesting. The only way this is 7. Okay, that's fascinating. Okay, let's look at it that way, potentially. We have 1 cage, 2, 3, 4, 5, 6. Right? So 1 cage, 2, 3, 4, 5, and 6. This adds up to 96. 96 plus 7 is 103. This must be 10 at most. Sorry, at least. So, and this is already, so this is, again, 1, 2, 3, 4, 5, 6 cages. That adds up to 96. This adds up to 7 because this is 9. So that's 103. 103 minus 90 is 13. This is at minimum 1, 2, 3, 4, which adds up to 10. That means this is at minimum 1 and 2, which adds up to 1 and 2. So this minimum is basically the amount this could be. So this has to be 1, 2, 3, 4 here, which makes this not 1, 2, 3, 4. The rest of this box has to be 5 through 9. 8 cannot be either of these. This 1, 2, 3, 4 in this 1, 2 pair means the rest of this box has to be 3 through 9. This can't be 3, obviously. This can't be 2. This is 5 or 6. If this is 5, this is at maximum 1, 2, and... Sorry. At maximum, it's 1, 2, 3, and 5 then, right? With 5. Because it can't add... Again, 16 minus 5 is 11. So this has to have 1, 2, and 3 no matter what. So this cannot be 1, 2, or 3. This cannot be 1, 2, or 3. This can't be 1, 2, or 3. So this is 4 through 9. This could be 1, 2, 3, 5, or 1, 2, 3, 4. So this can't be 8 here. Therefore, 8 has to be one of these 2 digits here, because this can't be 8 because of that 8. 8 then has to be one of these 3 digits. This has to be, this is, the remaining digits here are 4 through 9. What else do we have? What digits can this be? Okay, so this is at most 17. So we have 17 plus 16 here, which is what the most can be, which is 33. So this is 12 at least, which makes this 1 through 4. Right? Because if this was 5, that would mean this is at maximum 11. 11 plus 17 is 28. Plus 16 is 44 at most, which is not possible. Okay. What does that mean? I'm not sure. Let's see. What else do we have? One thing that's interesting is this cannot be 5. If this is 5, that forces this to be 6, which makes this a 1, 2, 3, 4 quadruplet, right? 6 must be added to 1, 2, 3, 4 to add up to 10. Well, that would force this to be a 5, 6 pair here. So you'd have a 5 and a 5, 6 here. That already adds up to 16 without a single digit. So this can never be 5 here. Five. If 5 were either of these two cells, they both see this cell. So this would be 5 plus 6, which would be 11. And then this is a minimum 1, 2, 3, which is 6 plus 11, which is 17. So 5 can never be here either. 5 could be either of these cells, right? What else do we have here from this? Why is it called Forever Young? I don't know. Can you ever have a 9 here is kind of a question. This is at minimum 3 and 5 here. So I think the answer is no. You can never have a 9 in this box, right? It's 3, 5, and 8 at best. Right? That's 16. Because we know this is 1 and 2. You can't have 3 and 4 here because one of 3 or 4 has to be here. So because of that, we know this can never have a 9. So 9 has to be one of these 3 cells here, which means this can't be 9. Can 9 ever be... I guess it could be 9 here if this is 3, 4, and 9. That's possible. Oh, that's interesting. Okay, so what happens... If this is 9 here, that means this is at best, at most 1, 2, 4. So this is at least 3. Right? So if we have 9 here, this means this can't be 9. 9 cannot be here. Where is the 9 in this box? It has to be here. So this is then 3, 4, 9 to add up to 16 at minimum. So this 3, 4 pair would eliminate 3 and 4 in the rest of the row. So this can't be 3, 4. It's a 1, 2 pair. This 1, 2 pair means this can't be 1 or 2 or 3 or 4. So it has to be 5 or 6 here. Well, say this is the minimum. 5, this is 3. You have 3, 5, and 8 already here, which adds up to 16. So this can never be 9. This has to be a 7 here. Right? And again, the logic is if this is 9, that forces this to be 9. 9 cannot have 1 and 2 anymore in that box. The minimum is 9, 3, and 4, and that is specifically adding up to 16. So that has to be 3, 4, and 9. That eliminates 3, 4 in the row. This is a 1, 2 pair. This can't eliminates 1, 2, 3, 4 in the row. This 9 can only be with 1, 2, and 3, or 1, 2, and 4. And this can't be 4. So this has to be 1, 2, 4 here, which makes this a 3. This is at minimum 3, 5, and 8. That's already 16. And therefore, this would have to add up to 17, which breaks the rule set. So this cannot be 9 here. It has to be a 7 here, which means this can't be 7, this can't be 7, or 8, remember. This 7 could be with 2, 3, and 4. So that's fine here, and this could be 1. So there's no problem with this being 3, 4, 9 in that case. So this is 7 and 8. Okay, because this is 7, though, what does that mean this adds up to here? We know this is again 16 at most, 16 at most, 16 at most here. 16 at most, that's 4. So 1, 2, 3, 4 cages. Say the 5th cage. So that's 80. 87, this is 7, plus 7 is 104. Therefore, this is 1 and 2, and this must be a 1 then. So this has to be 1 here. Right? Because this is 7 now. We know it can't be 9 because of the way that this works, and therefore this doesn't work that way. So this is 7. That means each of these must add up to 16 here. Guaranteed. Because this is the minimum amount you can have, and it's also the maximum amount that these cages can add up to. So this is 2, 3, 4 here. 1 cannot be here. 1 is obviously not there, but this could repeat here, but it adds up to 16 no matter what. So this is 9. This must add up to 7. So this is 5 or 6. This has to be a 7-9 pair to add up to 16. So this is 7, this is 9, which means this cannot be 7 or 9. This is 7. So this has to be 1, 2, and 4, which means 4 cannot be here. This can't have a 7 anymore. This must add up to 16, because again, the maximum values here add up to the minimum values that you can have with these cells. So this must be 16 also, which is 3, 5, and 8. So this can't be 8. This is 8. This is 6. This cannot be 6 or 7 here. This is 8, so this cannot be 8 here. So 8 has to be one of these 2 digits. This must add up to 16. This must add up to 16, and this must add up to 16. So this can't be 7 here, this can't be 7 there. 1 of 1 or 2 is here. This is 10. So it's either, it can't be 1, 3, 7. It could be, sorry, 1, 2, 7 it can't be. It could be 1, 3, 6. 1, 4, 5. Or 2, 3, 5. And if it's 2, 3, 5, that would eliminate too many 2s here. Too many possibilities here. So it's either 1, 3, 6 or 1, 4, 5. It cannot be 1, 2, 7 adding up to 10 because the 7's already taken in the box. Therefore, where's the 9? The 9 has to be here. This can't be 6. This is 9 with 3 digits adding up to 7. It has to be 1, 2, and 4. So this is 1, 2, 4, which eliminates 1, 2, and 4 in the rest of the row. So again, this is 1, 3, 6 or 1, 4, 5. So the 3 or 5 is one of these cells. This can't be 3 or 5. This has to have a 1 here. So this cannot be 1 here. This can't be 1 here. So this becomes a 2, 4 pair, which eliminates 2 and 4 in the rest of the box. This can't be 2. So this is 1. This is 2. 1, 2, 8 must be with 5. So this can't be 5. This is 3. This must be a 1, 3, 6 triplet, which eliminates 1, 3, and 6 in the rest of the column. This 2, 4 pair eliminates 2, 4 in the rest of the column, so this can't be 6, no 4 or 6, no 2, 3, 4. Therefore, that forces this to be 5, which means this can't be 5. This is 7. This can't be 5 or 7. This can't be 5, 6, or 7, so this is 8, 9, 8, 9 here. This can't be 7. This 5 means this is 1, 2, 3, 5 at minimum, so that's 11, which makes this a 5. So this is 5. This can't be 5. This can't be 5. This has to be 1, 2, 3 here. None of these could be 5. This can't be 5 or 9. These can't be 5. This can't be 2 or 4, so this is 3. 3 has to be one of these 3 digits. This 8 eliminates 8 here, so this is 9, this is 8. This can't be 7. None of these could be 7. 8 cannot be here or here, so 8's one of these two digits here. What is this digit? It has to, this is adds up to 17. This is 16 at most. That leaves this as 12 at least, right? We have 45 minus 17 is 28. 28 minus 16 is 12. So this is at least 12, which makes this then a 4. So this has to be 4. Which means this can't be 4, whereas the 8 in column 1 can't be here, can't be here, it has to be here. So this is 8. These can't be 4. It's a 1-2 pair, which forces this to be 4. This can't be 4 or 9 here. And it can't be 5. This becomes a 3, 6, 7 triplet, which eliminates 3, 6, and 7 from the rest of the row. This can't be 6. This is 1. This is 6. That 1 eliminates 1 here, so it's 2 and 1. This has to be a 4, 9 pair here. One of these is 3. This can't be 1 or 2. This becomes 3, 5, or 6. This can't be 5. This is 4, so this is 12 at most. Therefore, this cannot be 4 either place. This can't be 3. This 8 eliminates 8 here, so this can't be 8. This is 6. This can't be 6. This can't be 6. This becomes a 7, 9 pair. This eliminates not, 7 and 9 in the same box, so this is 8, which makes this a 9. Where's the 8, then, in this box? It has to be here, so this is 8. This adds up to at most 16, but it doesn't have to be 16. So this still could be 1, 2, or 4 here. The remaining digits are 1, 2, 4, and 7. And 4 cannot be either of these spots. So 4 does have to be here. 7 can never be here, because if this were 7, this would be at minimum 3, 5, 4, and 7, which is 19. So this is 1 or 2 here. 7 has to be one of these digits, which means 7 cannot be either of these. This is a 4, 6 pair, which eliminates 4 and 6 in the rest of the column. This can't be 4. This is 2. This is 4. This can't be 3. This can't be 2 because of the 1, 2 pair in the box. So this is 3. This can't be 3. Therefore, this is 6. If you had 5, you could have 1 with it, so that's fine. We have a 1, 2, 1, 2 pair in row 8, which eliminates 1 and 2 in the rest of the row, so this is a 4. This can't be 4. Which means this can't be 4, 5, or 6. This is a 7, 8, 9 triplet here. This is 4. That means this must add up to 12. So this must add up to 17. 16, sorry. 16, 17. That's 33 plus 12. So that works. 7 cannot be here. This is 4. One of these is 3. This is 4 or 9. What's the minimum here? It's 2. It cannot be 2 and 4. It could be 2 and 5. But 2 and 5 could be with 9. So that's fine also. This cannot be 8. What are the remaining digits? Okay, so we have 8 here. That means the remaining digits here have to add up to at most 8. So that's 1, 2, and 5 at most. Actually, this is 13. So then this must be 6 and 6, right? Sorry, not 6. 16 and 16. because these add up to 13, right? Yeah, so it's 16 and 16. Therefore, the other digits are 1, 2, and 5. 5 cannot be here, so this must be 5 here, which makes this a 1, 2 pair. This 5 eliminates 5 here, so it's 3 and 5, which makes that a 3. That leaves 6 and 7 here. This can't be 6 because of the 6 in the column, so this is 7, this is 6. This can't be 6 or 7, this can't be 5. We have a 1, 2, 1, 2 pair in column 2, which eliminates 1 and 2 in the rest of the column, so this is 7. This can't be 7. This is 4 and 6, so these two must add up to 6 here. This is 4 and 7, this must add up to 5. So this is 2 and 3, and this is 1 and 5 here. This 1 eliminates 1 here, so this is 2 and 1. This has to be 1, 4, 5, and 6 as possibilities, so this can't be 1 or 5 here. That leaves this as a 4, 6 pair here, which eliminates 4 and 6 in the rest of the row. This is a 2, 3 pair here. Let's see. Okay. This could be any of those. That's fine. This is 2, 4, 5, and 8 here. I don't think this can be 4. If this is 4 here, that makes this 9, so that's 13. But this can't be 2 because this 4 eliminates 4 here, so that's 2. This would be 5 at minimum, so this cannot be 4. These two are 6, 7, and 9 as possibilities. What's the minimum here for these digits? It has to be 6, 2, and 7, which adds up to 15. And with an extra digit, it must be 1. So this minimum is basically what the maximum this cage can add up to. So this is 6, this is 2, this is 7, this is 1. That makes this 3. This can't be 6 here. Right, so we have 1, 6, 2, 7. That adds up to 7 plus 2 is 16. This can't be 1 or 6. This is 4, 5. Where's the 1 in row 9? It has to be here. So this is 1. 2 cannot be here. This can't be 7 or 6, so this is 3. This can't be 3 here. This can't be 7, this can't be 7. So if this were 6, the problem with this being 6, though, is this would be 3, 6, and 8 at minimum. Which is 3 and 6 is 9 plus 8 is 17. So this can't be 6. This is 4, this is 6, which makes that 4, which makes that 5, which makes that a 6. This can't be 4 or 6. This can't be 4. This 6 eliminates 6 here, so this is 7, which makes that 6. The 7 eliminates... Ooh. No, that does work. 7 makes this not 7, so this is 9, this is 7, this is 9. This 9 eliminates 9 here, so this is 8 and 9. 8 eliminates 8 here, so this is 5. Neither of these can be 5. This 5 eliminates 5 here, so this is 8, which makes that a 5. 8 eliminates 8 here, so this is 4, which makes this 2 and this 4. This 2 eliminates 2 here, so it's 1 and 2. 9 eliminates 9 here, so it's 7. 4 eliminates 4 here, so it's 9, 4. This could be 8, 2 and 8. This actually has to be 2, which makes this an 8. And that's how you solve it. Yeah, I mean, fairly... I don't know. Not that difficult, I guess. You just have to know the sums, right? And that's a lot of calculation, really. And then just spotting where the actual restrictions are. Which I will admit is not easy to spot, right? This is, yeah, trying to find these restrictions. I don't know. You just have to look hard enough, I guess. It does take a while to find that. Anyways, I hope. Oh, it's forever young is you can't be greater than 16, so you'll always be 16 or less. I guess sweet 16. I don't know. I guess that's the that reference of forever young. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.